specifications. 38.211, probably not the most recent, but
actually, since we're on this topic of 3GPP and their different releases, because I'm trying to learn a little bit more about it,
okay.
I did see that we're on release 15. So is that the latest version then of release 15, and do they work kind of in buckets? I saw that they're working, like they'll eventually work towards release 16. That looks like they almost have different versions within the release 15.
You're correct. So there have been 3 major versions in release 15. The first one went out December of last year. They had a second major one where they tried to lock down everything that was going to be included in release 15, and that was in the June timeframe. And then September, they've done some cleanup, but the focus in September really has started to focus now on 16. So Rev 3 is the latest of release 15, and they identified it as V3, and they put the date. But yeah, so we're on release 15, Rev 3, and the focus in 3GPP is now on release 16. So most of the meeting content now is going to be release 16. Yeah, so within this, they have a topic on numerologies.
Yeah.
So let's dive into what that means.
Pretty early on, it looks like they talk about it.
If you look at spectrum, numerology really has a major play on how you divide spectrum up into individual tones that are used to communicate the data. And each tone will have a signal come into it that, based on where that signal is in time, it's going to define what the digital data is for that particular time. And so the numerology effectively defines what this delta F reference is. LTE is historically used this 15 times 10 to 3, so this is 15 kilohertz as the tone spacing. What's happened with 5G is we now have a numerology that's driven by this mu factor.
Okay.
And so you can think of LTE as being aligned with mu equals 0. And so you have a 15 kilohertz tone spacing. And what this mu factor does, though, is it now adds in a 2 to the mu factor times 15 kilohertz. So it goes basically 30, 60, 120, and 240 kilohertz.
Exponentially, it's growing.
Correct. And what 3GPP has done is they've partitioned off that less than 6 gigahertz is going to be working with 0, 1, and 2, and generally it's going to be 0 and 1. And then the FR2, the millimeter wave, is going to be focused on primarily 2, 3, and 4. And one reason for doing that is the tone spacing and filter requirements and the operating frequency, those all like to travel with each other. So as you go up in frequency for the main bandwidth, the spectrum, you'd like the spacing to also increase. It's just things work better when those are reasonably tracking each other. Now, what comes from going to a higher subcarrier spacing is if you take the inverse of frequency, you then get the fundamental time delta.
Okay.
So if you took 1 over 15 kilohertz, I forget the number, but the point is if you go to a higher frequency here, the subcarrier spacing, increasing that decreases the separation time-wise between doing